This question is related to the motion and Newton's laws. A student carried out an experiment to obtain the value of acceleration due to gravity g. A small ball was dropped from a rest and the motion of a ball was captured using a digital camera. The student counted the frame from the recording to measure the time for the ball to fall to the ground. A ruler was visible on the recording, enabled the student to measure the distance fallen by the ball. Use Newton's second law of motion to show that the acceleration of a ball is independent of its mass. So according to Newton's second law, the resultant force is equals to ma. And whenever there is a falling object without air resistance, the resultant force is equals to weight of an object. So the force which is acting on the object is weight without air resistance. So we can say the resultant force will be equal to weight. So weight is equals to ma. And weight is also given by W is equals to mg. So weight is mass into gravity. So in place of weight, I can write mass into gravity. So m is common here. M will cancel with m. So we can say that gravity and acceleration of a falling object will have the same values without air resistance. Our consideration is without air resistance, they will have the same value. State the equation that student should use to calculate the acceleration due to gravity. So basically, when object is falling and student is measuring, the object fall from certain height, student recorded the time and student measure the height using a ruler or the scale. So we will use equation of the motion which involves the height and the time. So which equation involves, and what is the initial velocity? The initial velocity is 0. So we have this equation s is equals to ut plus half at square, in which u is equals to 0 and acceleration is due to gravity and s is h. So we can say h is equals to, because u is 0, so this whole factor will be 0. So it will be half, acceleration is due to gravity, so g and t square. So we can use this equation h is equals to half gt square to find the acceleration due to gravity, or we can plot a graph between the height on y-axis and time square on x-axis, and the gradient will be equal to g by 2. A value of a g was obtained and was greater than the expected. Explain possible source of error. So why we are getting, look, the two factors on which the value of g depends here, that we know h is equals to half gt square. So we can say h over 2 will be multiplied 2h divided by t square is equals to g. So what can increase the value of g? If we are getting a higher value of a g, it means time recorded is shorter or the height measured is longer. That both factors can result in an increase in a value of a g. So what might happen due to the parallax error? Maybe we did not measure the height accurately. The height measured is like the measured value of a height is greater than the actual value. That's why we are getting a higher value of g. Or the time interval for a ball, the time recorded or counting the number of the frames, there is an error. So we counted less frames. So if the time which we calculated or we measured, that is a short time, it means we'll get a higher velocity of or higher value of the gravity. So you can mention and explain one possible source, and that would have produced a greater than the expected value.